Okay. It begins with mental arithmetic. 43 squared. 1,849. 89 squared. 7,921. 143 squared. 20,449. 306 squared. 93,636. 2,040 squared. 4,161,600. 52 times 57. 2,964. 106 times 113. 11,963. 208 times 203. 42,224. 1,004 times 993. 996,972. 10,004 times 9,995. Okay, well, so 10,004 times 10,000 would be 100,040,000. And so now you have to subtract 50,020. Okay, so 100,040,000 take 50,020. All right, so 99,990,000 first. So 99,990,000 989,980. Okay. Right, we'll switch now to JMC stuff. Hello. Okay. Right. I don't know how I'm going to be able to remember that. I don't think I could without a lot of time, so I'm going to have to just figure it out by looking at it. And the answer is 20 plus 26, so 46. Okay. Okay, those should be the other way around. How many distinct values do 2 plus 2, 2 times 2, 2 divided by 2, and 2 to the power of 2 yield? So we know that 2 plus 2, 2 times 2, and 2 to the power of 2 all yield 4. 2 minus 2 and 2 divided by 2 yields 1, and therefore they yield 3 distinct values. So 2 plus 2, 2 minus 2, 2 times 2, 2 divided by 2, and 2 to the power of 2 yields 3 distinct values, namely 0, 1, and 4. Which of the following yields a value closest to 0? 6 add 5 add 4. 6 add 5 take 4. 6 add 5 times 4. 6 take 5 times 4. Alright, what's the last one? Which of the following yields a value closest to 0? 6 add 5 add 4. 6 add 5 take 4. 6 add 5 times 4. 6 take 5 times 4, or 6 times 5 divided by 4. Okay, so go through them one by one. So we get 15, 7, 26, negative 14, 7.5. Try again because there was a noise. 6 add 5 add 4. Okay, begin again. So, which of the following yields a value that's closest to 0? 6 add 5 add 4. 6 add 5 take 4. 6 add 5 times 4. 6 take 5 times 4. Or 6 times 5 divided by 4. Go through them one by one. 15, 7, 26, negative 14, 7.5, so it goes, I'm trying to visualize 15, 7, 26, negative 14, negative 14, 7.5. I mean, it's the second one and I can see it. So which of the following is closest to 0? 6 add 5 add 4, or 6 add 5 take 4, or 6 add 5 times 4, or 6 take 5 times 4, or 6 times 5 divided by 4? The answer is the second one, 6 add 5 take 4, which is 7. So you are told that 0 is less than p, which is less than q, which is less than 1. Now, which of the following is the largest? Q minus p, or p minus q, or p add q over 2, or p over q, or q over p? Okay. Alright, so if P is less than Q, then we know that P minus Q cannot be the largest, so we can eliminate that one. We also know that Q over P is larger than P over Q, so we eliminate Q. We eliminate P over Q. So it's Q minus P, or P over Q, or their mean. Yes, it's Q minus P, or Q over P, or their mean. Okay, so Q over P will be greater than 1. Therefore, we can dismiss Q minus P. And in fact, their mean will be less than 1 as well. So it's obviously Q over P. So if we are told that 0 is less than P, which is less than Q, which is less than 1, and we have to decide which of the following is the largest. Q minus P, P minus Q, P plus Q over 2, or Q over P, or P over Q. We know that it has to be Q over P, as all the alternatives are either negative or less than 0. What fraction of integers from 1 to 8,000 inclusive are cubes? So 1 cubed is 1, and 20 cubed is 8,000, and we are including the endpoints, and therefore the answer is 20 cubes in total. 20 cubes in total, but they asked for the fraction. So it would be 20 out of 8,000, which is 20 over 800, which is 1 over 400. So what fraction of the integers from 1 to 8,000 inclusive are cubes? The answer is 1 over 400. Okay. Which could hold 10 liters? An airplane, a bucket, a cup, a dustpan, or an egg? The answer is a bucket could hold 10 liters, but also so could an airplane. So 2 of them. but also so could a very large cup if it was sufficiently large. And the same logic applies to the others, but just going based on everyday reference points, we say just the airplane in the bucket. If a half of a third of a quarter of a fifth of a number is 2, what is that number? So a half of a third of a quarter of a fifth is 1/120th. So x over 120 equals 2, so x is 240. So we say that a half of a third of a fourth of a fifth of 240 is 2. Find the sum of the even numbers from 2 to 20 and divide it by the sum of the natural numbers from 1 to 10. The numerator is just double the denominator. So the answer is 2. The sum of the even numbers from 2 to 20, all divided by the sum of the natural numbers from 1 to 10, is just 2. How many of the following are prime? 0 squared at 1 squared, 1 squared at 2 squared, 2 squared at 3 squared, 3 squared at 4 squared, 4 squared at 5 squared, 5 squared at 6 squared. Okay, so we have to go one at a time. And the very last one is 61. Okay, so it starts out as 1, 5, and who's next? 1, 5, 13, 25, 41, 61. So the answer is 4. 4 of them are prime. Okay, so I don't think I'll be able to memorize that. Well, I'll try. No, I don't think I can do that. That's too much. Okay, but for completeness sake, the answer is 3. Alright, that's a lot of noise. I don't think there's not really any structure to that at all, so I can't really justify spending time on that. Okay, 4 distinct positive integers multiply to give 110. Find their sum. So they are 1, 2, 5, and 11, and their sum is 19. So 4 distinct positive integers multiplied to give 110, and their sum is 19. Okay, so again, there is a lot of noise in this one. Seems almost... I think actually there's something to it. Okay. Which of the following is equal to 0.1 plus 0.2 plus 0.3 minus 0.4, all divided by 0.5? And the options we have are 0.01, 0.02, 0.04, 0.1, and 0.4. So the best way to do this is to just do the calculation. So let's see, I could say 0.1 add 0.2 add 0.3 is 0.6, and 0.6 take 0.4 is 0.2, 0.5 would be the answer. So it's 2/5, which is 0.4, 0.4. So if we are asked which of the following is closest to 0.1, add 0.2, add 0.3, take 0.4, all divided by 0.5, and we are given the options of 0.01, 0.02, 0.04, 0.1, and 0.4, we should say 0.4. A cake bakes from 11:40 for 1 hour and 35 minutes. What time does it finish baking? So the answer is 1:15 p.m. 1:15 p.m. So a cake bakes from 11:40 a.m. for 1 hour and 35 minutes, and it finishes baking at 1:15 p.m. Approximately how many 7.7 millimeter frogs would have to be placed end to end to make a 1 meter line? So it's 1000 divided by 7.7, or 10,000 divided by 77. Now 1000 divided by 8 is 125. But let's see. You multiply it by 12. No, multiply it by 13 instead. Because 7 times 11 times 13 is 1001. Times that by 13. Times that by 130. So I would say 130 is the closest. Okay, that's now time to oh no, you're not right. That's the one. Chapter 9. Find the exact length of the third side of a triangle with sides of length 3 and 5 and an included angle of 120 degrees. So we interpret that as lying between them. And we use the cosine rule. A squared equals b squared plus c squared minus 2bc cosine A. So a squared equals 9 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 120. So 34, take 30 times this one. Oh, I get it. You're a half. 34 plus 15, 49. Square root that, and we get 7. So for the triangle whose sides are 3 and 5 and whose included angle is 120 degrees, the third side should be 7. Seems so. In a triangle ABC, where side A is 6, and side B is 6 root 3, and angle A is 30 degrees, find all possible values of angle B. Well, you can do the sine rule. Sine of angle B over 6 root 3 equals sine of 30 over 6. Sine of 30 over 6 is 1 over 12. And 1 over 12 times 6 root 3 is root 3 over 2. And sine of 60 is root 3 over 2, but also so is sine of 120. So B is 60 or 120. So in triangle ABC, where side A is 6, side B is 6 root 3, and angle A is 30 degrees, the two possible values of angle B are 60 and 120. Find the exact obtuse included angle in a triangle with an area of 15 and two sides of length 6 and 10. We use the area rule. The area of the triangle is half of A times B times the sine of the angle between them. So half of 6 times 10 is 30, and 30 times the sine of the angle between them is 15. So the sine of the angle between them is a half. So it's either, oh no, they mentioned it was obtuse. That means it's 150. So 150 degrees is the obtuse angle in the triangle with an area of 15, whose two sides that we know of are 6 and 10. And we're trying to find the angle between them. State the number of vertical asymptotes of the graph y equals tan of x over 2 in the interval x ranging from 0 to 360 degrees inclusive. Okay, if you halve the argument, then it will be stretched out by a factor of 2. So the usual vertical asymptotes 90, 270, 450, and so on. But now it will just be 180 that we have to care about. So just one. Yeah, just one. Oh no, actually, I'm gonna be late.